Subject of thermodynamics. I myself Shivam Dixit welcoming you all on this beautiful series that is for GATE 2027, and today is the third lecture of basic thermodynamics subject, and I have told you that just wait a minute please, right? So just wait. So this is the third lecture, and in previous two lectures we have discussed about the basic concepts, right? I told you that there are three concepts through which the question can be framed. The very first concept is properties are exact differential. We have already solved number of questions on that, and then we have discussed about the second topic through which the question can be asked, that is ideal gas properties and properties of its mixture, means properties of the mixture of ideal gases. And today we are going to talk about work and heat part, and there is one very interesting questions is being asked on the topic, that is displacement work, correct? So we'll discuss that, right? We'll discuss about we'll discuss about the displacement work or closed system reversible work. But before that, one more topic is there which I want to tell you, that is related to the very basic property of thermodynamics, that is temperature, means thermometry. So today we are going to talk about the thermometry, right? Means temperature measurement and how the temperature is being measured, and what are the what kind of questions could be asked from this particular topic. And another one is the closed system reversible displacement work and the PV diagram. So these three things we are going to talk today, right? And this topic is very, very important, right? I would say it is a 4-star topic, right? It is a 4-star topic. So up to now we have seen three topics basically. One is properties are exact differential. I would like to give 2 star for that particular topic. Then properties of ideal gas and its mixture, I would like to give 3 star for that topic. Then today we are going to talk about the thermometry. Again, I would like to give here 2 star for this topic, but this topic is very much important, that is 4-star topic. And the next topic is first law of thermodynamics, that I would give you give it approximately 5 star, right? That is a 5-star, very, very important topic. So let me start with the temperature first. So what is temperature? Like I told you that in most of the properties, right, most of the properties can be defined macroscopically as well as microscopically. So if you talk about macroscopically, then temperature is a property by the virtue of difference of that property heat flows. Whereas if I talk about microscopically, then temperature is the property or we can say temperature is the average kinetic energy of the molecule, correct? Temperature is defined as the average kinetic energy of the molecule, right? Okay, average kinetic energy of the molecule, right? Now temperature is defined by the 0th law of thermodynamics. The definition which I have given to you, that like temperature is the property by the virtue of difference of that property heat flows, that is basically comes from 0th law of thermodynamics, which states that if two bodies are thermal equilibrium with third body, then they are equilibrium with each other. Means if a body A is thermal equilibrium with body B, means temperature of A and B is same, at the same time the body C and B temperature is same, then the temperature of A and C is going to be same, even though both are not physically in touch, correct? So that is basically the meaning of this 0th law of thermodynamics, and the definition of temperature is actually comes from this particular law, or temperature is defined by 0th law of thermodynamics. Not only this, the temperature measuring devices, that is called as thermometers. So various kind of thermometers are there, right? And all those are actually based on the 0th law of thermodynamics. So basically there are two significances of 0th law of thermodynamics. 0th law of thermodynamics define the temperature, correct? And 0th law of thermodynamics is the basic law for temperature measuring devices, that is thermometer. Now how a thermometer is basically designed. So basically, if you want to design a thermometer, then there are two steps. The very first step is to find out a property which vary with respect to temperature. For example, you may have seen that mercury glass tube thermometer. Earlier, that doctor used to use that, right? So mercury glass tube thermometer, if you look at, then if you increase or decrease the temperature, then the height of mercury column is basically changes. So here if you see, the property which vary with respect to temperature is the height of mercury column, and that property is called as thermometric property. So basically thermometric property is a property which help to measure the temperature, correct, and which varies with respect to temperature. Okay, uh, like there are different kind of thermometers. For example, one I have already told you, that is a mercury glass tube thermometer. In that case, the height of mercury column is a thermometric property. Similarly, there is one more a thermometer, that is constant volume gas thermometer, where pressure is a thermometric property. Another one is a constant pressure gas thermometer, where volume is a thermometric property. There is a thermistor, right, digital thermometers, right? So thermistor, which is based on Wheatstone bridge, and the thermometric property is electrical resistance. So if you change the temperature, then the electrical resistance of thermistor is going to change. So thermistor is a kind of resistance which is sensitive with the temperature. If temperature will change, then resistance value will also change. It is used as a temperature sensor, right? It is used as a temperature sensor. Okay. Now the next one is a thermocouple, which is based on the Seebeck effect. According to the Seebeck effect, if two dissimilar materials are form a junction in such a way that the both junctions are at different temperature, then then a EMF is introduced in between, right? So here basically EMF is a thermometric property. If you change the temperature, the amount of EMF is going to change. And the reverse effect of Seebeck effect is basically Peltier effect, which is used in a refrigeration. Now let's talk about another very important, nowadays very much famous, that is pyrometer, right? Pyrometer, you have seen nowadays in even doctors are using it, even in most of the places, in hospitals or hotels. Whenever you are entering, at that point they measure the temperature with the kind of device seems like a gun, right? So that is basically a pyrometer, where intensity or radiation or wavelength of the radiation is basically the thermometric property. So I hope you know about all those things. So this is a theoretical part. Now there are two basic methods for the temperature measurement, right? So the first step, right, thermometry, you know what, thermometry is a science. Please try to understand. Thermometry is a science which is used to measure the temperature, right? Or we can say thermometry is a branch of science which deal with the measurement of temperature with the help of zeroth law of thermodynamics. And in thermometry, a property which vary with respect to temperature is found first, and the property which help in finding the temperature is called as thermometric property. And after finding this property, we will calibrate our thermometer. And for calibration, there are two basic methods. The first one is two reference point system. Please listen here. First one is two reference point system, right? So in this method, basically two references are going to be used. The very first reference is ice point. Ice point, that is nothing but a 0 degree centigrade, and another one is steam point. If any confusion is there, you can ask me, because as I told you, right, that in this series we are not that much focusing on the theoretical part, because as far as GATE is concerned, very less number of questions are being asked from sir, what is the work pressure you feel in this job, and where are you from? Okay, Sai Kumar, I am from Uttar Pradesh, Lucknow, and believe or not, there is zero pressure at all. Zero pressure at all as far as teaching is concerned, right? So teaching is a kind of skill, right? Teaching is something that I enjoy, even most of the teacher enjoy, because if you are not enjoying teaching, you cannot continue. And one most important point I would like to share here about the teaching, that you are getting the money uh, for the thing that you want to do, right? And that you love to do, right? Whereas in other jobs, it is not like that. In most of the jobs, you will see that people don't want to do that, but they are only doing for the sake of getting money. And that is a requirement, and we are forced to do that. There is nothing wrong in that, right? Not only one, two, there are out of 100 people, 90 people are doing their job because they have to feed their family. They have to feed their family, right? Maybe they are not interested, right? But still they have to do. They are doing actually. But I'm very much fortunate. I'm very much fortunate. Sir, kya class English? Right, I'm very good English. Yeah, I'm very good English. I'm very good in English. Maybe you'd know or not. Sujay, I know you. Sujay Roy is one of the most talented guy, and he's very much dedicated as far as I know. So the point is very much simple here. The point is very much simple. Yeah, there are some work, right? I'm very much frank here with you guys. I'm very much frank here with you guys. The question which is asked by Sai Kumar, I would like to answer it, that as far as teaching is concerned, as far as the part where I'm involving the most, 95% of our job is the teaching, and I really enjoy it. I really enjoy it, right? The people who have attempted my classes, the people who have attend my classes, you just ask him. I enjoy my class at all, right? But in YouTube there are some restrictions, because it is an open platform, right? Whereas paid classes, if you talk about, or you app classes, if you talk about, that is restricted to our student, right? Here not necessary to be student, there might be some more people may come, right? So we have some restrictions here, right? But in class I enjoy the most. Even in YouTube also I enjoy the most, but still I would say there are some restrictions, right? uh Only 5%, 95% is teaching. I enjoy a lot. Only 5% part of my job is there, right? I would not share what is that, which I personally feel boring, right? Only 5% work is there, so that is manageable, no problem at all. In whole world, if you see, 90% people are doing the job that they don't like. I'm doing the job in which 95% thing I love to do, so there is no problem at all. Then let's talk about the another comment by Ruchika. Okay, Ruchika, sir, do they ask how a particular thermometer works? Okay, in GATE exam it is not going to be asked because the theoretical kind of question, right? They will never ever ask, right? In ESC, right? In ESC or any state government exam or PSUs exam, if you see, there might be possibility that they may ask thermometer is based on the which principle, sorry, right? Or thermistor is based on which principle, or thermocouple is based on which principle, Seebeck effect, that pyrometer is based on which particular law, right? So these kind of questions can be friend, but as far as GATE is concerned, no, this question is not going to ask. So whether should I learn or not, it is depend upon your goal, right? If you are still in BTech and you have to give the semester exam for thermodynamics, then you need to learn that how a particular thermometer works. As far as GATE is concerned, no need at all, okay. Now, due to my friend father, did I come visit him, sir. Today class is shifted to recording. Okay, enemy, please take care of your friend. Please take care of your friend, and you attend the recorded classes. And as per, it is a very much, I would say it is a, very important work for you. So please go and support your friend. Even today or tomorrow, if it is needed, you support him. And if you can attend the recorded classes, but in recorded classes also, if you feel any problem, please uh, write your comment either in this comment section, or you can write your question in a comment section, or directly in the Telegram. You can directly write to me. I will definitely reply you, correct, because you are doing something that is really important for today. Okay, सुजय सर, मेरा आईआईटी बॉम्बे में थर्मल इंजीनियरिंग में हो गया. वाह सुजय, राइट. सी सुजय, actually I don't know about whether you got IIT or not, but as per your dedication for attending the classes, I judge that, right? I judge that you are a good student, and finally you got IIT Bombay, that too also thermal engineering. It's really an appreciable job. Congratulations. Do great in your life. Do great in your life. Do good research, right? Do something good for your country, for your parents, for your own dreams, right? And IIT Bombay will give you all the opportunities which actually required, right? So only the thing is, you have to work hard to grab that opportunity, right? So very much congratulations to Sujay Roy. very much congratulations. Hey, hi Ruchika. Enemy go, भाग जाओ यार, जब मारेंगे तुम लोग. ये जानबूझ के बोलता है ये लड़का. Sir, if I completed this class, will it fully cover thermodynamics for SSC JEE exam? I am not going to give you the wrong suggestion, right? I will not give you the wrong suggestion to increase my views or something. I am very much frank, and I'm very much, directly I'm saying that no, it is not sufficient for SSC JEE exam. No, it is not sufficient for SSC JEE exam. The reason is very much simple, because in SSC JEE exam, theoretical questions are asked, right? 60 to 70% questions are theoretical. And as I told you that here I am discussing the concepts for the GATE exam, where theoretical things are very, very less. So I'm very much frank with you. I'm very much, because if I give you some wrong suggestion, right, that okay, you attend the class, my class, I'm the, no, it's not going to give me the happiness, right? So my point is very much clear here, right? My point is very much clear here, that the lecture series which I am going to give you, the lecture series which I am providing you, that is basically GATE prospective, where I am majorly focusing on the numerical problems, right? I am majorly focusing on numerical problem. For SSC JEE, you need to go through with the theoretical part also. So I would suggest you to, you can attend the class, right? You can attend the class, you will get the core concepts, but still you require some more theoretical part, right? So for that you need to refer some other resources also. Okay, Chandan sir is here. Sir, I did studies homework. Very good, enemy. Very good. Enemy, your name is Shashank. I forget, right? So his name is Shashank. In YouTube, his name is Enemy's God. Enemy's God. You people, waste people. Saying was, sir, how to maintain consistency? Wow. Some sir, Sai Kumar, I am working as a bark scientist. A bark scientist asking me that how to maintain consistency. You are the bark scientist, Sai Kumar. That, and you, I'm very much sure that without maintaining consistency, you it's right. I am very much sure that when you got this bark scientist job, then you have already maintained consistency in your previous life. but still I'll tell you, right? Sir, when you scrolled me like that, I feel nice. Okay, if that girl reply my message or not, but your reaction is priceless. Okay, Shashank. Sir, please give me suggestion. Thermal engineering is good for me. Very much good. See, Sujay, one thing I would like to share here. Branch, right? Whatever branch you are getting, every branch have sufficient or enough, opportunities. Even some branch have more opportunities. I agree with that, and some branch have enough opportunities. So in mechanical engineering, the best or job perspective, if you see, then the maximum opportunities are with the machine design. Okay, and job perspective, thermal also have much more good opportunities. But as far as research is concerned, thermal have more opportunities than even machine design, right? So you have chosen a very right, you have chosen a very right, a branch. No problem at all. Just work hard, you will get something very good in life. Sir, I have enrolled for ESC paid batch. Will studying it help me preparing for SSCJ exam? Definitely, definitely. Now I would say, right now I would say yes, because in ESC batches we used to teach theoretical part also in very much detail, and that part is more than sufficient for SSCJ exam also, because I have seen that there are number of questions which are asked in SSCJ exam that are nothing but a ESC PYQs. The only one suggestion to you, if you have taken ESC, or if you want to take ESC paid batch, then it is more than sufficient. Only additional thing that you need to do is SSC JE PYQs. SSC JE PYQs. Okay. I recently selected Bark. I maintain consistency, but I am debating right now due to location change, and I have doubt, can I do Bark up to my lifetime or resign and go to other countries? I must say, don't go anywhere, right? Bark will give you the maximum possible opportunities, right? So I would personally not suggest to think outside of it. Do good in the Bark itself, right? Do the research, do the continue your studying, right? Continue your study, and Bark will support you to study. If you want to go for masters or PhD, definitely Bark will support you. So it is my personal suggestion, Sai Kumar, continue with the Bark, right? Bark will give you the every possible opportunity which is required. Sir, my aim is to go into the PhD future. Please suggest me the opportunity comes after PhD. Lot of opportunities you will get, especially in R&D sector, right? Nowadays, nowadays every company have to establish their R&D labs, right? So there are very good opportunities for PhD students in R&D sector, research and development. And other than this, you can go for a teaching, right? Teaching industry, and there are a lot of demands. Whatever IIT, whatever NIT, whatever state government college, whatever private college, everywhere there is a requirement of good teachers. There is a requirement of good teachers. You also studied in some college, right? And you are studying in one college, and your friends are studying in different colleges. You just ask, every single college there is a deficiency of teachers, especially good teachers. So if you wants to be a teacher in future, PhD is one of the good opportunity. But I feel stressed because of new location. It is for Sai Kumar, I understand it, right? I very much understand it. Even I have also gone through this phase. So but it is only for some time, right? It is only for some time, Sai Kumar. You need to be strong for this particular time. You need to be strong, right? in your time there is opportunity you have that you can talk to every day your parents, you can do the video call and all. When I left from my home, at that time there was no facility of video calling. Even calling is also not that much frequent, because that was very highly charged. So even we cannot talk every time, right, when we get free. So hardly we used to talk once in a 2 to 3 days. So be strong, Sai Kumar. You will do great in job. You will do great in your life. How to adopt a new surrounding, achieve good position. Don't worry about it. Every human being, not only human being, every living thing have this ability in their body, that they are adopt their surrounding. They adopt their surrounding. Your body is the design in such a way that it will adopt automatically. Just be strong, that's it, nothing else. Sir, come back to the class please. So last 10 minutes, let's chit chat, don't mind. Okay, sure. My job is good for preparing AC parallelly. It's depend upon you, but I personally feel that you are in a good place, so it's better to continue. Okay, let's discuss about the topic. Right. By clearing your doubts, I little bit deviated from the topic. Let's talk about the topic. So basically, I told you that there is one property which actually vary with respect to temperature. So we will assume here the linear variation of it, right? Means T is equal to A plus B into P. T is what the temperature, A and B are the constant, and P is a thermometric property depending upon your system. Let's say it is a constant pressure gas thermometer, then P is a volume. If it is a thermistor, then P is nothing but a resistance, electrical resistance. If it is a mercury glass tube thermometer, then P is a length. Okay, now if I write this particular equation at ice point, right? If I write this equation at ice point, then this value will become 0, A plus B into P ice. Now this P ice value we can find out experimentally. We can find out the value of P ice experimentally. There is an experimental setup. Hope you have seen in your college laboratory. Okay. Now talking about steam point. Then it is 100 degrees centigrade, that is equal to A plus B into PS. Now if you solve this, you will get A and B value. So A is going to be cancelled out. So B value will come 100 by PS minus PI, and A value you will get minus 100 PI by PS minus PI. So finally you will get like T is equal to 100 Pi by PS minus Pi plus, this is minus, actually this is minus, here it is plus 100 by PS minus Pi into P. Now with the help of this particular equation, you can find out the any unknown temperature. Please listen here carefully, that for, let's see, Pi and PS is known experimentally. There is one experimental setup in your laboratory, and with the help of that device which you want to calibrate, you can find out the value of Pi and PS. You can measure the value of Pi and PS, and for any unknown P, you can find out the temperature, right? So this is one method. Another method is single reference point system, right? Single reference point system. Okay, single reference point system. So single reference point system, basically there is only one property is going to be used. Here as a reference, that is triple point of water. of water. The triple point of water is basically 273.16 Kelvin. Okay, so now here I will consider relation at T is equal to AP. At triple point, if you find out that A value will come 273.16 because A is equal to T at triple point. Okay, I'll write otherwise. So at triple point, if you write, then it will come T at triple point is equal to AP at triple point. So what is value of A? A value will come 273.16 temperature at triple point divided by that property at triple point. So from here you will get a T is equal to 273.16 P by P at triple point. So with the help of this particular equation, you can find out the unknown pressure. Generally, the gas thermometers are calibrated with the help of single reference point system, and other thermometers like mercury glass tube thermometer, thermistor, thermocouple, right, all these are actually measured with the help of two reference point system. So I'll suggest you to write it down once. I clear ESC prelims but fail in mains. Okay, no problem, you can continue, but I personally feel that you are in good place. Please write it down. Sir, I am taking leave, sir. Miss you, sir. I listen it later. Okay, and okay, Shashank, you can go. You can go. Okay, shall we move? Okay. Now here one more point I would like to share here. This is the method, but the questions are mainly asked on one very common thing. That is you have seen that there are different kind of temperature scales, degree centigrade, Fahrenheit, Rankine, Kelvin. There are number of scales. Now I would like to share here one very interesting fact. That all the temperature scales are arbitrary. All the temperature scales are arbitrary. What do you mean by all the temperature scales are arbitrary? What do you mean by that? What do you mean by that all temperature scales are arbitrary? The meaning is very much simple. That see, whenever a new temperature scale is designed, then you need to tell. For example, I want to make one temperature scale, a new temperature scale, let's say degree Shivam, right? I want to make one temperature scale degree Shivam, right? Then I need to tell that what are the ice point in my scale, what is the steam point in my scale, and what is the variation, right? So and these things are completely arbitrary, right? For example, if I talk about, let's say, ice point is required, steam point is required, right? So in degree centigrade scale, if you look at, then ice point is 0 degree centigrade and steam point is 100 degree centigrade. Now you cannot ask to the Celsius, you cannot go and ask the Celsius that why you are giving ice point as a 0 degree centigrade. why you are giving a steam point as 100 gain. No, you can't ask. Why? Because these are the arbitrary, sorry, these scales are perfectly arbitrary. Arbitrary means whatever you want, whatever they want, they can put. Similarly, if you see Fahrenheit scale, then here it is a 32 Fahrenheit and this is 212 Fahrenheit. Similarly, if you talk about Kelvin scale, then it is 273.15 Kelvin. It is 373.15 Kelvin, and it is an absolute scale. It starts from 0 Kelvin. Similarly, if I want to make one scale, right? If I want to make one scale, then if I want to make one scale, then at ice point will be what? Ice point I can put anything. Let's say I'm putting here 378.6 degree Shivam, right? Sorry, degree Shivam. Similarly, I can put here like 4 or I can write here 123.6 degree Shivam, right? Now you cannot ask me that why you are giving 370.6 here, why you gave here 120, because it is arbitrary. Whatever I want I can put. Even if you see, I have given like more value to ice point and less value to steam point, that is also fine. Anything, it is perfectly arbitrary, it is only depend upon me. Okay, right? That is the different point, that most of the other scales are designed for some perspective, and this is arbitrarily, means no one is going to use this scale. That is a different story, but you cannot say that the scale is wrong. No, it is a correct scale. That is a different story, that I am only going to use this, no one else is going to use this scale. Okay, so this is one very interesting fact about temperature scales. Yeah, anything else? I clear bar, KC, prelims, SSC, JEE, RA. Wow, you have clear this much number of exams and finally choose bar. Your choice is very good. Okay, I want to talk to you. Definitely you can put a message, you can put me a message in a telegram. I will share you the telegram here. So this is my telegram channel. This is my telegram channel. You can put me the personal message, right? I will share my contact with you, and then we'll talk over a phone. Okay, we'll talk over a phone. Okay, so if you actually want any kind of help, right, so I'm here to help you. This is my telegram channel. Here you just sir, how to connect to you Instagram account to my Instagram? I have Instagram, but I would not suggest you to go for Instagram. Go for Telegram. Okay, my age is 22. Sir, did I achieve anything? Yeah, you achieve a lot. You achieve a lot, but you have to achieve little even more, right? Right, you have to achieve even more. You have achieved a lot, but still you have to achieve more. Okay, okay, so let's talk about this particular problem. So I would request you to solve, I would request you to everyone to solve this particular problem. Everyone, please solve this problem. Everyone, please solve this problem. Everyone, please solve this problem. Yes, correct. Very good. Yes, definitely, definitely. Have you solved this? Sure, sure, Sai Kumar. I have something to tell you. Don't worry, we'll talk and we'll discuss that how can you achieve even more. Don't worry. Okay, so there is a new temperature scales degree N has been proposed where the normal freezing point and boiling point is. So freezing point is basically 500 degree N and normal boiling point is 100 degree N. If the temperature of system is measured to be 0 degree N, what is the temperature in degree centigrade? Okay, now please try to understand. So here basically if I write here ice point and steam point, so in degree centigrade we already know the value, right? In degree centigrade we already know the values, right? So this is basically 0 degree centigrade, this is basically 100 degree centigrade, right? And if I talk in degree N, if I talk in a degree N, then this value is 500 degree N and this value is 100 degree N. Okay, this is a 500 degree N, this is a 100 degree N. Very good, Sai Kumar. Very good, Sai Kumar. I really appreciate. I really want to appreciate your hard work, and it is your hard work that you are getting such a great position. And I'm very much sure that if you continue doing this hard work, you will achieve something very big in your life. Okay, so let me write the relation here. So I can write N is equal to A plus B into C. So at ice point, N value is 500, A value A plus B, C value is 0. So basically you will get A value as a 500. So now the relation can be written as, N is equal to 500 plus B into C. Now N value is how much here? 100 degree, right? 100 degree N is equal to 500 plus this is also 100, B into 100, right? B into 100. So finally B value will get -4, I think so, right? -4. So now final equation will come N is equal to 500 minus 4C. Now they are asking that at 0 degree N, right? At 0 degree, right? At N is equal to 0. If you put here N is equal to 0, so you will get 4C is equal to 500 and C value will get 500 by 4. So 500 by 4, how much it will come? So this value will come 125 degree centigrade. So final answer is 125 degree centigrade. So I hope don't give up any situation, bro. Sai Kumar, you are the great, bro. Okay. Right. Let's solve one more problem. It's better to give this problem as a homework, right? So you just note it down, this problem, and this is a homework problem. This is a homework problem. Please solve it either now or better to solve after the class. Just note it down. Note it down, or you can take the screenshot also. Very good, Sai Kumar. So this is a homework. Let's move on to the next topic, that is closed system reversible work, right? Closed system reversible work. Now I see my parents hard work. Very good. Sai Kumar, whatever hard work your parents did, you paid it off. You paid it off. Okay. Let's talk about the closed system reversible work. So if I consider here, please listen here carefully. If I consider here, let's say we have one piston cylinder arrangement, and initially the piston is somewhere here. Initially the piston is somewhere here, and here one gas is contained. It is contained of a gas which have pressure is P1 and volume is V1. Now here number of stoppers are there, and we are going to remove one by one, right? We are going to remove the stopper one by one, and finally piston is reaches somewhere here. Finally piston is reaches somewhere here, which have the final volume is P2 and V2. The final volume is P2 and V2. The final volume is P2 and V2. If I draw this situation in PV diagram, then initial condition is P1 V1, right? Initial condition is what? P1 and the volume is V1. Final condition is what? The final condition is P2 and V2. P1 V1 and P2 V2, and the process is given something like this, and process is also exactly defined here. Why? Because it is a quasi-static process, and quasi-static process can be drawn in any property diagram. So that's why I have drawn this particular thing, right? Now if you want, right, if I consider a very small segment, if I consider here, let's say in this particular case, if I consider here like between 1 and 2, there is one random state I am considering, right, where the pressure P is going to be a right act in the piston, and it is going to displace by very small volume, that is very small displacement dx. So basically if you look at here, then P is equal to basically F by area, and F can be written as P into A. Now so the work is equal to basically F into the displacement, small work dw, F into displacement, F can be written as dw is equal to P into A into dx. Now what is A into dx? A is the area of the piston and dx is the displacement. So this is basically the change in volume. So dw value coming like P into dv. Means if your piston is moving a very small distance, of dx, then the work done is dw is equal to pdv. Now if you want to find out the total work when piston is moving from state 1 to state 2, then you have to perform integration. So w value will come integration 1 to 2 pdv. Now please try to understand, in thermodynamics, our convention is very much simple, right? Our convention is very much simple. Work by the system is taken as positive. Whereas work on the system is taken as negative. Or I can say that expansion work is considered as a work by the system. That means it is a positive work. Expansion work is always positive, whereas compression work is work on the system, which is always considered to be negative. And this formula is basically following our convention. So whatever work you will get from this one, you will it is very easy to calculate. Okay, now talk about this particular situation here. So at given pressure P, if the volume changes dV, then what is the area of this particular strip? So area of strip, if I consider strip, area of strip value will come P into dV. So what is the total area? This total area I'm talking about, the total area when projected on volume axis. So total area in PV diagram when projected on a volume axis will be integration 1 to 2 P dV. That is basically closed system reversible work, right? Closed system reversible work. Now please try to understand, there is one very important significance, right? There is one very important significance of PV diagram, that the area under the curve when projected on volume axis in PV diagram gives closed system reversible work, right? So these two things only are required for this particular topic. Only two things are required. One is the work, actually work is closed system reversible work, that is W is equal to integration 1 to 2 PdV, and the area under the curve when projected on volume axis in PV diagram gives closed system reversible work. Okay, hello sir, hello. Sir, I need your help in NIT Jalandhar or Jaipur. VLSI design is good or not? VLSI in most of the colleges are very good. I personally feel I don't know much about the electronics department in Jalandhar as well as Jaipur, but overall Jaipur is little bit better, so you can go for it, right? And VLSI is nowadays something like, if you are working hard, right, then you will get a very good rank. Sorry, if you are working hard, then definitely you will get a very good opportunities in VLSI in coming future. So the only thing is, whatever college it may be, either NIT Jalandhar or NIT Jaipur, both will give you the enough opportunities. The only thing is, you need to work very hard to get into your desired output. Okay, so these are the point. Now here there are some standard processes, right? There are some standard processes, my dear. For example, for constant volume process, if volume is constant, then dV value will become 0. Change in volume will become 0, means constant volume work will be 0. If you talk about constant pressure process, so if pressure is constant, then pressure will come out, then it will come P into V2 minus V1. If it will be isothermal process, right, isothermal means PV is equal to constant, then work value will come P1 V1 ln V2 by V1. If it is adiabatic process, means PV to the power gamma is equal to constant, in that case it will come P1 V1 minus P2 to divide by gamma minus 1. If it is a polytropic process where n is between 1 and gamma, then the work value will come P1 V1 minus P2 to divide by n minus 1. Clear? Is it clear? I said every aspirants to in this chat or work hard, not to. Very good. Very good sign. Let's solve some problem based on this, right? So this is the one problem that I have given to you. Please solve this. An ideal gas undergoes, okay, this process is basically isothermal. P is equal to constant, and this is basically PV to the power 1.4 is equal to constant. Please solve it. And this is basically V2 volume. No, sorry. I think it is not, no, it is not constant pressure. Wait. Okay, I think it is also not required. An ideal gas undergoes a cycle as shown in figures. The net work output you need to find out. Okay. You need to solve net work output. Okay. First, we need to calculate what is the value of V2. First, we need to solve for getting V2. The net work transfer they are asking. So basically, net work transfer is the area of the cycle. Area of the cycle in PV diagram gives net work transfer, or you can do one thing, that net work is equal to W1 to 2 plus W2 to 3 plus W3 to 1. Process 2 to 3 you can consider adiabatic. It's better to do one thing. Here some changes are required. Let's say this is also not given. Right, this is also not given, right? Please listen here. This is also not given. There are few changes I am going to do here, and this is PV to the power 1.4 is equal to constant, and this is basically PV is equal to constant. Right, now you solve. Please solve now. V3 is also not given, right? I change little bit question. Now this is the correct question. Now everyone please solve this. Please solve this. So for this, what we are going to do, first I will consider 3 to 1 process, right? Please consider here 3 to 1 process, that is P3V3 is equal to P1V1. So P3 value is 100, V3 value I don't know, P1 value is 300, and V1 value is 0.5. V1 value is 0.5, right? Okay. So from here V3 value you will get the 1.5 meter cube, right? Right. So this value V3. Now consider 2 to 3 process. 2 to 3 process means P2 V2 to the power 1.4 is equal to P3 V3 to the power 1.4. So P2 value is 300, V2 value we don't know, P3 value is 100, V3 value is 1.5 to the power 1.4. So calculate V2 value from here. Calculate V2 value from here. So sorry because I am sharing my personal life here, but my intention is to motivate others. Very good. No, you are doing great here, Sai Kumar. You are you are inspiration for all those people who are blaming the resources, right? The people who are saying that I don't have enough resources to get into the uh, institutions like BARC, then you are one of the example for them. Okay, great. May God give you all the success in your life. This is my best wishes with you. So basically you will get 0.684 meter cube. So V2 value is known. Now calculate W. So W value will come how much? W1 to 2 plus W2 to 3 plus W3 to 1. So W1 to 2 is P into V2 minus V1 plus W2 to 3 is P2 V2 minus P3 V3 divided by 1.4 minus 1 and plus P3 V3 ln V1 by V3. Just put the value. So this value is 300 into V2. V2 value is 0.684 minus 0.5 plus P2. P2 value is 300 into 0.684 minus P3. P3 value is 100 into V3 value is 1.5 divided by 1.4 minus 1 plus P3. P3 is 100, right? P3 V3 ln V1 by V3. So ln V1 by V3 may 0.1 by 0.5 by 1.5. You just solve this and tell me the answer. You just solve this, right? You just solve this and tell me the answer. So finally I can say 0.684 minus 0.5 into 300. So the first value will come 55.2 plus this value, that is 300 into 0.684 minus 150. So this value will come 138 plus, actually this value will come in minus actually. So 0.5 divided by 1.5 ln of this answer. So 150. This 164.8. So you will get a 28.4 kilojoule. So this is going to be your correct answer. This is going to be your correct answer. Now I would like to give you some right. Now I would like to give some homework problems. So this is the second homework problem. One homework I have already given, and one more I would like to give you this problem. These two problem I would like to give you, and one problem related to uh, uh, one problem related to the temperature measurement I have already given, and two problem I am giving you as a homework for closed system reversible work, right? And if you have any challenges, if you feel any challenges in the solution part or any difficulties there, then I am available at this particular Telegram channel. So you can directly connect with me in this particular channel. I will suggest each and every student to join this particular Telegram channel, where I would give you all the possible suggestions, solutions, and here lot of previous toppers are there. They also helping the students. Okay, so join this particular channel. Okay, so this is all about today's topic, right? So I hope you all are able to understand. So tomorrow we'll meet at the same time and we'll discuss the first law of thermodynamics for closed system. Thank you. Bye bye. See you. Meet again. So let's meet tomorrow at